this magnesium has undergone a reaction, and it went from no charge indicated here, so there's nothing up there, it's 0, to having a +2 charge. Was it oxidized or reduced? Well, the magnesium lost, remember it went down, right? So it lost electrons, right? And so, sorry, on ours it went up from 0 to +2, so it was oxidized. Okay. Now, the hard part for many students is the fact that when we do these, that they don't happen in a vacuum. That something causes things to be oxidized, and something causes something else to be reduced. And so this idea of oxidizing agents and reducing agents can be a little difficult here, but treat the word agents as if it flips the meaning. And we use the word agent for similar things all the time. A music agent, their job isn't to play music. A sports agent, their job isn't to exhibit their sports. It's to allow someone else to play music or play sports. And so an oxidizing agent, its job is to cause something else to be oxidized. All right? And so how does it do it? Remember, what we're looking at is electrons being transferred. So here in this one, CuO plus H2, all right? This has a +2 charge, this has a -2, and my hydrogen is actually neutral. And so when this reacts, now I have copper that's got no charge, and this one we'll talk about later has understood charge, okay? And so the copper oxide here, copper 2 oxide, this copper gained 2 electrons. It gained 2 electrons. Now where did they come from? They came from these hydrogens, right? So hydrogen gave those electrons over to the copper. Notice the oxygen then would be treated as a -2 here, and each one of these has a plus. There's 2 of them, each one is a +1. All right, and so hydrogen lost the electrons, copper gained them. Now these numbers over here, water is not ionic. We're treating it as if it's ionic. So to put these numbers, we use these numbers called oxidation numbers. And their definition is terrible. Their definition is, it's the charge something would have if it had a charge. The charge something would have if it had a charge. There's a whole list of rules for those, but for us, we're going to just look at the fact that, hey, this copper was a +2, now it's a 0. We'll treat it as a charge. So we'll treat this as a +1 for each hydrogen and a -2 for the oxygen. That gives us the oxidation numbers. And we just pretend everything is going to be ionic. And remember, we're going to do subscript times charge plus subscript times charge. That'll equal the total charge. And for everything that we do, got cut off there. Everything we do there, it's going to be based off of that. So you can really just look at the electrons being moved. All right. Now, if the copper was being, it went from a +2 to a 0, and so it gained electrons. All right. It was reduced. What caused it to be reduced? It was this hydrogen. All right. And so if it is oxidized, it's automatically the reducing agent. If it's reduced, it's automatically the oxidizing agent. That's just the easiest way to look at it. Okay. So our oxidation numbers, we talked about those, so not too big a deal. So if you can find what's being oxidized and what's being reduced, then they're automatically, if you know what's reduced, then you automatically know what's being oxidized. You'll notice the oxygen was just along for the ride here. Now, I could have done this a different way. I could have done this when I looked at my CuO plus H2. We said this went from a +2 and it went to Cu that was neutral. And it went from a +2 to a 0 and it was reduced because it gained electrons. Let's look at it a different way. How much oxygen is here? How much oxygen is with my copper? 1. How much oxygen is with it down here when it's by itself? None. And so it lost oxygen. If it lost oxygen, it reduced the amount of oxygen. It was reduced. That's why I want you to know all three definitions. And so if I know this is reduced, I come over here and I can say this is reduced, which makes it automatically the oxidizing agent. This was oxidized. It had no oxygen, now it has oxygen, and that makes it the reducing agent. Agent flips the meaning. Alright, easy enough. Alright, so that takes care of chapter 8. A lot of terms, one skill. Our one skill then was our pH. Okay, so practice those, study over the definitions here. So acids, bases, oxidations, reductions. Practice the pH problems. They're not super difficult, but you do need to practice them. Alright, we'll catch you on the next one.